Well, hello everyone, and welcome to Pacific Engineers Inc.'s Tech Talk. We're happy to have you here today and excited to share with you what our company has to offer. Our company, Pacific Engineering, known as PEI, is located in Roca, Nebraska, which is just outside of Lincoln, Nebraska. We now are housed in 72,000 square feet of space where we focus on the design and manufacturing of advanced composite structures. We have this focus that enables our customers to save weight without compromising performance. Again, we save weight without compromising performance of the component. We meet or exceed the performance requirements for ship or shock, environmental, vibration, fatigue, toughness, etc. One of the key factors and features that we talk about, we're not just a composite vendor. We understand how to join metal to composite parts, critical interface as we work in the world of composites. Our principal experts, i.e. some of the PEI staff, are world known and have over 40 years of experience, and I would say really approaching 50, in composite design, engineering, and several patents are held. Our in-house facilities includes some of the latest state-of-the-art control systems that allow us to do filament winding. A key thing is one is 60-foot long, 8-foot diameter, 4-axis system of filament winder, and that's important. What allows us to take on things like a shaft, a classical shaft of a DDG, for example, is in the 50 plus some range. A segment of that shaft, by having a winder can do 60 feet, it obviously allows us the ability to make a large shaft. We work from the philosophy of build, test, build, test. This allows us to learn, improve, adjust, and continue manufacturing as we go. And it's a process that we're quite comfortable with, and we believe is quite successful in doing so. I'm going to move to the next slide. But before I do that, I would say part of our commercialization transition success was actually a phase 3 in our all-up round torpedo canister that was completed from the concept and supported that effort in 9 months. It's known as push to bush. So we feel comfortable in our ability to transition and, as we move forward. Also who we are. Since these slides were produced and getting ready for this, PEI is a critical player in building rapid on-demand portable medical platforms known as pods that are used for testing and vaccinations in the war against COVID-19. So PEI is also being known for that effort as we engage in COVID-19. The current Navy challenge is one of reducing sustainment cost while you maintain the performance characteristics of the component. Design and development of advanced composites and assemblies, simply stated, will extend the part and service life for various components. That's the challenge. I would also add that when you lose control of your sustainment and maintenance cost, you erode your total budget, and it impacts other products. It impacts other acquisition costs. It impacts the ability to buy new components. So this is a constant and a big challenge that the Navy faces. So how can we meet the operational need and improve the situation? We believe that the materials are inherently corrosion resistant, mitigate cost repair, restoration, or replacement. They are well suited for the extreme environments, high stresses, fatigue, etc. It is well known that metal and salt water do not go well together because it leads to corrosion. Harsh operating environments require materials that are able to withstand the elements while still preventing corrosion and meeting all necessary requirements. Improved materials, and they must be cost effective. Clearly, the benefits, we get increased capability, longer service life, and really we get at this, the reduction in the total ownership cost of programs. To meet the call, we have developed multiple variations of lightweight composites to meet varying degrees of weight, strength, and fire, smoke, and toxicity needs. Different manufacturing methods provide us with the ability to tailor composites depending on the Navy's needs. And as observed in the photo there, it's a sample of a couple pictures of our components. This slide is a little dated, however, the key points I want to make. Once we select the fabric and resin for this program and we're involved and insert our nanomaterials, we see the improvements. Our current seals, for example, weighs in excess of 500 pounds. By making this out of composite, the units can save 40%. Okay, same with the seals. The existing shafts we run numbers where we can reduce the weight of the shafts by 50%. Those in the audience doing the math, that is a significant reduction when it comes to these components. The purpose of this slide, the bottom line, it saves weight, reduces the weight by 50%, reduces sustainment cost, and that says it all. Our facility allows us to build our technology outside and transition them out to the fleet. We have identified multiple transition platforms for our technology and have multiple transition advocates within PEO organization, NAVC, and private industry. In summary, come talk to us. I put my contact information up there to reach us, and we'd be more than happy to talk to you. If you focus on composite shaft, other technologies, launch canisters, deck launchers, missile components. As I stated, our transition, we're looking at other components like supporting the war against COVID-19. With that, I will entertain any questions that you may have. Thank you.